All right, here we go on lesson 3.4. Still in the modeling unit. This one's on computer aided design, which we all call CAD. There's two main types of CAD software out there. The first is more simpler. It's called surface models, where basically it's only dealing with the outside of the design, the outside surfaces that you can actually see. So it's photorealistic imaging of a product, offers some machining data for manufacture, but no data about the interior of the product. So examples of this would be SketchUp or Blender. You can't run a stress analysis on stuff like this because it has no idea what's going on inside. It makes it easier for the software to run, but more limited. What you guys are more familiar with are what's called solid modeling CAD. And this is going to be your SolidWorks, your Inventor, Onshape, Pro-E, which is Pro Engineering. Clear representations of the finished product. Provides complete set of data, including the internal dimensions and volumes. So you can actually run those additional tests like flow analysis or stress analysis. Virtual prototyping. Making your prototype can be super expensive. So if you can make it virtually on the computer and get the same results, same tests, then that saves you a lot of money. These are photorealistic CAD-based interactive models that use surface and solid modeling. These can be considered digital mock-ups. We're going to talk about bottom-up and top-down design. Bottom-up, the example that IB gives, is the process by which the Mars rover Curiosity was created followed a bottom-up strategy. What that means is each individual part was designed first to make sure it was functional for what it needed to do. Then it was brought together and they figured out what the final assembly needed to look like in order to incorporate all those additional parts. Versus top-down design. I'm going to throw this in present mode. Top-down design, which originates as a concept and gradually evolves into a complete product consisting of components and sub-assemblies. It starts with the finished assembly in mind, and then works backwards to what the parts would have to be in order to get that assembly. Okay, so two totally different ways of doing a design. You can see the little graphic on the bottom right. Digital humans. These are computer simulations. It enables a product to be developed more quickly. More design iterations in less time results in higher product quality and meets human requirements more accurately. Basically, you're able to test your product on a human. Digital humans. Digital prototypes are cheaper than physical prototypes. Products are safer as a result of more thorough analysis. Improved productivity results from enhanced automation. Digital humans enable manufacturing plants to develop more quickly, manual workflow to be optimized, and it improves worker safety. It reduces compensation costs resulted from accidents. For example, the image on the top right could be a facility that either designs or tests these automobile tires. And before you actually build the factory, maybe you want to set it all up virtually so you can test it out and make sure everything's where it needs to be and there's not going to be problems. Your workers aren't going to be injured because of a poor design. Digital humans can be used to ensure that people can access the parts and equipment, check that workers can effectively use any hand tools, check that the task can be performed safely without requiring inordinate strength or exposing people to a risk of injury. In this image, you're seeing somebody work as if they were working in the front engine area under the hood of a car. They're not really doing that, but that's what they're simulating. Motion capture. The recording of human or animal movement, for example, video, magnetic or electromagnetic mechanical devices. Person wears a set of acoustic, inertial, LED, magnetic, or reflective markers at each joint. The sensors track the positions of the markers as the person moves, and this gets developed into a digital representation of the motion. It makes it look very realistic. Motion capture. can reduce the cost of animation. Otherwise, it requires the animator to draw either each frame or keyframes that are then interpolated. Saves time and creates a more natural movement than manual animation, but it's limited to the motions that are anatomically possible. Motion capture records the movements of an actor, not his or her visual appearance. Captured movements are mapped to be a 3D model, allows the designers to design better ergonomic products, allows the designers to understand the user's physiological requirements. In this case, I believe this is a member of the U.S. women's soccer team, and they were brought in, a bunch of the women, to wear all those markers and go through the motions for the motion capture. So I don't know if it's a video game or what was being created, so it'd have natural movements. Haptic technology interfaces the user via the sense of touch. For example, your smartphone. When you have a touch screen like that, that is haptic technology. Also known as force feedback technology, works by using mechanical actuators to apply forces to the user. User becomes part of the computer simulation and interacts with it, enabling the designer to observe the user's performance and to design a better outcome. It can also be used in situations where it's difficult to train in the real environment. Feedback devices need used in home entertainment consoles. An example of this. Virtual reality, known as VR, the ability to simulate a real situation on the screen and interact with it in a near natural way. Animation, the ability to link graphic screens together in such a way as to simulate motion or a process. Finite element analysis, FEA. We tend to just call this stress analysis, but the real name, the technical name for stress analysis, is actually finite element analysis. It's the calculation and simulation of unknown factors in products using CAD systems. Simulating stresses within a welded car part is the example that IB gave. International-Mindedness. Improved communication technologies allow designers to develop collaboratively by different global teams in a 24/7 basis. Because around the world, people are up and working at different times. And since everything is going digital, these files and designs can just be sent back and forth to each other via email, and it works great. TOK. How is new knowledge acquired through the use of digital models? Does technology allow us to gain knowledge that our human senses are unable to gain? And I put a picture of a stress analysis there. Is that something that is that knowledge we can now gain that we otherwise would not have been able to gain? Aim 10. The use of CAD to simulate the conditions in which a product will be used allows the designers to gain valuable data at low cost. For example, simulating the flow of air across a car exterior negates the need for a car and wind tunnel. Okay, so obviously a student could do the design and test on the left, whereas it would take a lot of money and resources to actually get that car and run it in an actual wind tunnel, like what's happening on the right.